Hello everyone and welcome to another video in our EigenLayer Learn series. In this video, we are going to talk about AVS and talk about some interesting features associated with them. So AVSs are actively validated services. As the name suggests, these are applications or infrastructures that need some form of consensus or validation for their transactions. Now, for example, think of an oracle. The oracle provides a result for a particular activity or for a particular event. However, how do you know that that event that the result provided by the oracle is trustworthy? That's where that oracle can use some form of consensus to make sure that multiple people or multiple parties are validating that result and thereby making it trustworthy. This is an example of an actively validated service. There are multiple different services and there are a few that are running on EigenLayer as well, which I'll talk about in the later part of the video. So, what is an AVS? An AVS involves setting up specific services where stakeholders, including stakers, that is us, and operators, actively participate in the consensus process for various applications. These applications, the AVS, right? So, how do they function? In the AVS, operators and stakers use specific contracts to manage interactions, right? We'll see the architecture diagram of this, but we are the stakers and we interact with certain contracts on EigenLayer. And then there are AVSs that are associated with EigenLayer that interact with certain contracts. And then there are operators that interact with certain contracts to ensure compliance with the services rules. So there are different processes like staking, restaking, delegating, and validating operators. So what are the different ways or what are the different processes involved in the AVS? The first set of components is the on-chain components. The on-chain components are the contracts that we are talking about. So there are different contracts like the AVS directory, the strategy manager, and the delegation manager. And then there are off-chain components like operators. The biggest off-chain components are operators. There are different organizations that can come and register as operators and they perform certain validations and manage the data outside of the blockchain. Now, this is the interesting slide, which is what I wanted to cover in this video essentially. I'm just going to move my face away. Okay. And if you see this slide, this is an architecture slide of how AVSs work. I took this from the official website diagram. And I'm going to use a small annotator just to kind of show you what's happening. Now, if you see this, it seems a bit complex, but it's actually very simple. So, as we mentioned in the previous slide, there are two components. One is the on-chain component, which you see on the left, and one is the off-chain component that you see on the right. Let's start with the on-chain component. The on-chain component, the stakers interact with EigenLayer by depositing assets into the strategy manager. So the first thing to notice here is that there are three core contracts in EigenLayer: the AVS directory, the strategy manager, and the delegation manager. Of course, there are multiple other contracts as well when you see the GitHub repository, but these are the three core contracts. And the stakers interact with EigenLayer by depositing their assets into the strategy manager. Let's take a quick look at the strategy manager. So the functions of strategy manager is to allow stakers to deposit their liquid staking tokens into the corresponding strategy, allow the delegation manager to remove the shares when a staker queues a withdrawal, and allowing the delegation manager to complete a withdrawal by adding shares back to the staker or withdrawing the shares as tokens via the corresponding strategy. So the main function of the strategy manager is to handle accounting for individual stakers. If you see the contract also, which is available on GitHub, the strategy manager.sol, you see that one of the main functions is a deposit into strategy, which deposits the amount of token into a specified strategy, right? So the stakers interact with EigenLayer by deploying assets into the strategy manager. The next thing that is happening is that you have the delegation manager. So stakers also actually, when we restake, we get an option to delegate our tokens, right, to different operators. So stakers also interact with EigenLayer by choosing which operator they want to delegate to. And this happens via the delegation manager. Let's take a quick look at the delegation manager also. So here we have the delegation manager, and the main functions of the delegation manager is to allow stakers to delegate to operators. So there are different operators. For example, Encode Club is an operator, and Nethermind is one of the operators. We have several other operators that are registered on the site, right, that you can find on the EigenLayer side. Now it allows stakers to be undelegated from operators. Like you can delegate to a particular operator, you can decide to undelegate, of course, and then it handles the withdrawals and withdrawal processing for shares in both the strategy manager and eigenpod manager. Now the interesting function that you will see in the delegation manager.sol is this register as operator. Now in order to delegate to a particular operator, the operator has to be registered as an operator. So you see this, you have operator related functions which you can find in delegation manager. So you register as an operator, modify the operator details, update the operator metadata, and then delegate to. This is where the caller delegates their stake to an operator. So you can go through this function as well, and then a couple of different other supporting functions. Undelegate, for example, when you want to undelegate and withdraw and stuff. Now this is and then the rest of this is basically different AVSs that you see. So each of these AVSs can actually, each AVS will have their own set of contracts, because they'll have their own set of logic, what do they want to do, etc. As long as they are able to liaison with EigenLayer via some sort of interface. So in this case, Service Manager acts as the liaison, and then they have their own particular contracts, the way they function and all of that, and they liaison with the EigenLayer core contracts. And as a client, you basically have the UI, which then interacts with the on-chain dApp that interacts with the AVS and such. Now the off-chain component of this is the operator nodes. These are equally important because the operator nodes are the ones that run the clients of the AVS that they are subscribed to. So they could potentially run multiple AVS clients, or they could, just depending on their computing power and capacity, they could run as many AVS clients as they would like. And this is basically just like your software node running software that is specific to their AVSs that they have opted in for serving. So these are the operator nodes that perform their own, functionalities and stuff, and they liaison with the AVSs, and the AVSs liaison with the EigenLayer protocol. The operator nodes should also be registered with EigenLayer, of course, and then there are some protocols around that as to how a particular operator can get registered with EigenLayer. You can find on their documentation. I believe that there isn't too many constraints to be registered as an operator, as long as you have the ability to run these AVS clients, you have the computation power that you can provide, etc. So it's fairly simple, I think, to be to become an operator. And so this whole thing is just different set of operators which are trying to run their own AVS services that they have subscribed to. So that's pretty much it, like the architecture, and it's fairly simple. It is you have the on-chain components on one end, and you have the off-chain components on one end. The on-chain components are the contracts and the AVS, so your EigenLayer core contracts, AVS contracts, main on-chain components you have to think about. And then for the off-chain components, you have the operators, and all of them kind of liaison. So this is the interesting architecture of AVSs, and this is one of my favorite parts, and something that I spent a while doing some research for. That what are the current AVSs, or what are some interesting things that are coming up, right? EigenLayer is touted to be one of the innovations in the space, because what can you do now as from an AVS standpoint, right? So let's start with one of the interesting ones that I have learned about, which is Witness Chain. So Witness Chain is a DePIN based AVS. So DePIN is your decentralized physical infrastructure, and this is trying to provide DePIN coordination amongst different projects that are in the in this space. So Witness Chain enables DePIN projects to share info about their location, their physical location, network capacities, and more. This which makes sure that there is a network for these DePIN projects to actually interact with each other, and they can also benefit from the information that they share with each other. And this is an AVS on EigenLayer. So they use some type of validation or consensus in order to make sure that the information that is being shared is actually legit. So very interesting project. The next thing that I want to talk about is the Align network that you see here. So Align Network is trying to do something interesting, as in they are trying to secure IPFS infrastructure with restaked Ethereum. So that's also quite interesting, because you have pinning services and all of that on IPFS, which pins the data in decentralized storage. But if you can maybe validate or add some sort of consensus layer, or reward, make sure that you can secure the data by using these restaked ETH, then it can be pretty cool, right? So a lot of innovation in that space. Then Novastro is a gamified L3 for parallelized restaking. So this is also running or about to be run as an AVS on EigenLayer. I came across this, which is called Slinky Scan. They also have another their parent project called Slinky Network, and they are in AVS, which enables creation of micro AI dApps. Super cool that I found. Of course, we all know EigenDA, which is data availability for rollups. One of the DA solutions that's becoming quite popular of late, and there are projects like Versatus and others that use the EigenDA solution. And then this is again something very, very interesting that I came across, Automata Network. They are trying to build a multi-prover AVS with TEE co-processors. So just to quickly break down this jargon, co-processors are like a system processors that help you with faster computation, that help you perform faster computations in addition to the computation that you're already performing. Like it helps you perform additional computations. So for example, the idea of ZK co-processors is becoming very popular, where it helps you perform off-chain proof verification stuff. And then FHE co-processors, which are for fully homomorphic encryption, those are becoming popular. And TEE, also known as Trusted Execution Environment Co-processor, will ensure executional integrity and help you perform computations much faster. So Automata Network was also something that I found was very interesting, and I'll put links to their blogs as well, all of these AVSs. There are lots of different projects as well that are coming up, and there is a ongoing hackathon, so I'm sure there are a lot more AVSs that are being built. And as a builder, you can also build your own EVS, which is a small tutorial that I will try to cover in the next video. And so AVSs are here. This is a nice sort of a revolution of being able to build services using existing crypto economic security provided by Ethereum. So I'm very, very excited about this progress, and hoping to see how it turns out. Thank you, and I will see you in the next video.